Well, I keep noting that the functions f of x equals logarithm base a of x and f inverse of f of x equals a of x. These are inverse functions. Well, if you don't remember those, let's just quickly review. First of all, f of x and f inverse of x are the kind of functions that undo one another by composition. That means that if I were to take a composition of the functions f of f inverse, that's an open circle, of x, right? That means, in other words, if I substitute in f of f inverse of x, the two are the kind of functions that will undo one another. So they just result in x. The domain and range of the functions and the inverse function are reversed. In other words, all of the x values that we get in the original function become the y values in its inverse, and vice versa. All of the y values in the function, the original function, become the x values of the inverse. And that has an effect on the domain and range of the function. In other words, whatever the domain of the function f of x is, it will be exactly equal to the range of its inverse. And the same thing goes for the domain of the inverse, right? The range of f of x is exactly equal to the domain of the inverse function. Okay. And finally, we can often solve for an inverse function by changing x and y in the function equation and then solving for y. If you recall, let's try this just with a really simple example. If I had a function like this one, f of x is equal to 2x plus 3, and we were interested in finding the inverse of this one-to-one function, right? Remember, they have to be one-to-one. Then we could rewrite it by switching the values of x and y in the function. So x becomes 2 times y plus 3 in the inverse function. We isolate y in the new equation, and that should be minus. Let's try that again here. Talking and writing at the same time. X minus 3 equals 2y. So x minus 3 all over 2 is equal to y. Means that our inverse function is equal to x minus 3 over 2. Right? So these two functions right here, well, of course, the domain and range is all real numbers for both of them, so that's not a big deal. But we can certainly see that taking a composition of these two functions, f of f inverse of x from below, in our example, testing them shows that if I take f of x, which is 2, and I multiply it by the inverse function x minus 3 over 2, and I add 3 to it, you'll recall that what should happen is that our functions, the 2's cancel right here, x minus 3 plus 3, should result in simply x. And it should work the other way around as well. And so when we have inverse functions, right, these were some important points to remember.